Let me share. You want to start the recording?
This meeting is being recorded.
All right. So we are slowly getting there. We are losing some people as expected because it's a long day, but we continue to go until that. We are recording this anyway, so you will have it for your reference. So what we're going to cover now is connectivity to the external layer 3 domain. I will clarify the different types of L3 outs we have, and there were also some questions already asked on the Q&A about, okay, what happens when you start extending subnet across sites? How do you deal with the fact that you send the subnet out on both sides at the same time, right? Solving asymmetric routing issues. We're going to talk about a couple of options here, how to handle that, and a third option will be discussed in the next session about the services integration. And the last part that we'll cover in this session is about, in this part, is the intersite L3 out. I will clarify what intersite L3 out is. So without any further ado, let's go different type of L3 out. Well, you know what L3 out is. It's a logical construct to connect to the external network. From the beginning of from the early days of ACI, we have been supporting L3 out, which basically is configured in a VRF Lite end-off way, which means on the border leaf, you specify the border leaf, the node that you want to use to connect out, you specify which links to use, and then for each VRF, you create a dedicated L3 out, or you create a shared L3 out, usually in common, that different VRF, different bridge domains defined inside the fabric can use, right? So we have this capability of having per VRF, per tenant L3 outs, or L3 out that can be shared, okay? We scale up to a certain number. I think we have 400 L3 out per border leaf. If you do dynamic routing, we can go up to 800 if you do static routing, okay? So this is the recommended option and the most deployed option, okay? Border leaf L3 outs. Now, in release 501, we deliver another approach on the border leaf, which we call it SR-MPLS or MPLS handoff. What that means is that we replace the VRF Lite approach, where for each L3 out, for each VRF, you have a different routing protocol and routing peering, with a single control plane and PBGP EVPN, surprise, surprise, which is established between the border leaf and the WAN edge router. This PBGP VPN control plane is used to exchange rich bit of information for all the VRFs that we want to connect to the external network, okay? And on the data plane, we are actually using an MPLS tag on the links between the border leaf and the WAN edge router, assuming that these links are directly connected. And this MPLS tag essentially identifies the different VPNs, the different VRFs, that the traffic belongs to, and allows the data center PE, the WAN edge router data center PE, that you see the models that we support in this release 501, to basically map the traffic to the right VRF before sending it into the MPLS core, okay? This is mostly used by, I said it in the beginning, in the introduction, is used by telco customer service provider that they want to leverage an MPLS segment routing enabled core, either to interconnect different data center or data center to remote leaf location or data center to branches, right? And they want to use that SR segment routing core to enable traffic engineering functionality, okay? So specifically that position for that, but going forward, even enterprises may be able to leverage this if they want to use a single control plane instead of doing the VRF Lite approach. The third option is the use of Golf L3 outs that we have been supporting for quite some time, which similarly to the MPLS handoff that I just discussed, use a single control plane and PBGP EVPN. The control plane is not between the border leaf and the external routers, but between the spines and the external router, right? So with Golf, basically we connect the WAN edge router or the data center PE, as you want to call it, to the spine instead of to the border leaf. So the concept of border leaf disappear. We introduced Golf 4 years ago, I believe, and it was for large scale, for service provider that wanted to connect a large number of VRFs into the external network. We still support golf. We do not recommend for new deployment to go the golf route because we don't plan to do more implementation in adding new functionalities on golf. But let me be clear, if you have already golf or your customer have golf in production or they want, and I'm thinking about Ola as well, my friend Ola, or if you have other customer that they want to deploy golf, it is still supported. It's a supported option as long as you are okay with the functionality that we support today. For example, we don't have layer 3 multicast support on golf, etc. Okay, and the difference with the MPLS and DOF I showed you before is that in the data plane, we use VXLAN between the spine and the external router to basically differentiate the traffic that belongs to the different VRFs. Okay, now independently from the type of L3 out you do, and the rest of this presentation focus on the border leaf L3 out because it's the most common, right? You need to decide, first of all, how to define external EPGs that are associated to the L3 out, specifically for a multi-site deployment. The external EPG, and I assume you know all about this because it's a basic ACI concept, each L3 out can have one or more external EPG associated. The external EPG is a representation or modeling of the external destination that you can reach through that L3 out, right? So basically you map external destination to an external EPG. You can map the entire external world, so you map with a 000/0, which means all the traffic coming in, that L3 out will be associated to that single external EPG. And why do we need to associate traffic coming in the fabric to an external EPG? Because we need an EPG construct to be able to apply a contract, right, between external entities and internal EPGs, okay? And that link between external entity and internal EPG is this concept of external EPG, right? So I can apply a contract between the external EPG and the internal EPG to control the policy for this type of communications. Now, when we are in multi-site, each site will have its own L3 out. This was from the beginning. At the beginning was a requirement of multi-site. Actually, this has been changed, and we will see with the inter-site L3 out functionality. For what concerns the external EPG, you can actually define a single external EPG object, right? Which basically means, if you paid attention to the previous lecture, that you define that external EPG object in a template mapped to both sides in this example, and then that single external EPG object is going to be created in both fabrics, and you can locally map it to each L3 out, right? To the L3 out in Site 1 and to the L3 out in Site 2. The advantage of using the single external EPG is when the L3 outs in the different sites provide access to the same external destinations, right? Then it makes sense to have a single external EPG object because it simplifies the creation of the policy on the multi-site orchestrator, right? I create a policy that says external EPG to red, external EPG to green. I need to specify the external EPG only once, right? Because it's a single object, okay? So that's the recommended approach, but doesn't change the fact that the L3 outs are actually independent L3 outs that you configure independently in each site, okay? It's just the tying with external EPG that is common. You can actually have scenarios where you have a separate external EPGs defined in each site, and this is usually useful when the external EPG provide access to different external destinations, okay? In that case, you may want to use different external EPGs so you know exactly what policy you want to apply depending on which external resource is trying to access internal EPGs, okay? Both are supported. There are pros and cons. Normally, I see people doing this because normally the external EPG and the L3 out provide access to the same external destination. Now, independently from how you configure that, and I wanted just to mention it as, what are the best practices, what we need to do, and this is a problem that we had in data center interconnect in DCI, in the DCI world for forever, it's how to solve the problem of asymmetric routing, right? So when I have a subnet, an internal subnet, 10.10.10, in this case, that is stretched across two sites, Site 1 and Site 2, normally I announce that subnet out on both sides, okay? And so that means an external user trying to access an endpoint in that subnet could be lucky and get to the right L3 out in the site where the endpoint is, or could be unlucky and get in the border leaf of Site 1 where the endpoint is actually located in Site 2, right? When that happens, from a forwarding perspective, is not a problem, right? Multisite will do its job. Traffic comes in, gets to the border leaf. The border leaf will send it will know where the endpoint is, or they will send it to the spine, and then the traffic through VXLAN will go to the Site 2 destination endpoint. But when the endpoint responds, most likely the traffic will use the local L3 out to go back to the same external destination. And now I created an asymmetric path where my SYN went through the firewall in Site 1, my SYNAC goes to the firewall in Site 2, and I break communication, right? I cannot establish my TCP session, right? Typical issue of asymmetric traffic across independent stateful services. How do we solve this? 3 ways, okay? Way number 1 is using a networking tool, which is the capability that ACI has of announcing host route information, right? So in Site 1, I'm going to announce the specific host route information for the .10 address, in Site 2 for the .11 address. Then once the host route reaches the external WAN edge router, the WAN edge router could do different things, right? It could inject it into the WAN if the WAN is capable of accepting host routes, or it could use Lisp. I could create a JD tunnel between the WAN edge router of different sites so that I redirect the traffic there. The goal is I want to ensure that I always traverse the same firewall for traffic going in and out of the fabric, right? Because if I make it symmetric, I don't have problem of breaking my connectivity, okay? Now, when I enable this host route, and enabling host route can be done at the bridge domain level, you see here there is a flag, and Joe will show you at the bridge domain level on MSO. When I enable the host route information, I need also to be sure that these host routes, for example, that are sent out Site 2, are not received back through the L3 out of Site 1, right? The internal endpoint host route should always be exchanged using the EVPN control plane. If I allow that prefixes to come back also from the L3 out, I may end up in some scenarios where I break my east-west forwarding using the VXLAN. Okay, so my strong recommendation is filter this host route information on the WAN edge router connected to the data center so that you don't send these host route prefixes back into the multi-site environment, okay? This is option number 1. Option number 2 is, well, I don't want to create a symmetric traffic path across different stateful service device. Well, let's not deploy different stateful services device. So I could deploy an active standby firewall pair, right? Obviously, this works, but it will force all the traffic in and out to be through the same firewall connected to Site 1, to the L3 out of Site 1, right? So in a true multi-site deployment, if the 2 sites are in different continents, you don't want to do that. If instead the 2 sites are built, there are 2 fabrics inside the same physical data center or 2 buildings of the same campus because you build them for scale, then this could be definitely an option, right? And you avoid that creation of asymmetric paths through the different firewalls. The third option that allows to solve this problem is actually using the service node, the service graph, and we'll cover in the next section. But before I go there, I want to clarify one last point for what concerns connectivity to the L3 world, which is basically intersite L3 out. What is an intersite L3 out? It's a new functionality that has been released with Multisite from ACI release 4.2.1 and MSO release 2.2.1. Before then, the communication with the external world in a multi-site design was only possible using the local L3 out, right? So in this example, endpoint in Site 1 could talk to the external world to the L3 out in Site 1, and the endpoint red could only talk to the L3 out in Site 2. We couldn't do something like this where an endpoint sitting in Site 2 could talk to something connected to the L3 out in Site 1. And that's something is not necessarily the WAN, right? Because I would argue that if it is the WAN, normally each site will have its own L3 out with redundancy, so it's not really a problem of losing the WAN connectivity in a site. It's just that that L3 out may get connectivity to things like mainframes, firewall, load balancer, and you may have scenarios where a mainframe is only connected in Site 1 and have a client in Site 2 that needs to communicate with that mainframe, right? That's where inter-site L3 out becomes handy. And in order to support inter-site L3 out, we have to change how inter-site forwarding works, okay? And we also had to add some control plane enhancement, right? So through the MPBGP EVPN control plane that I described before, we only exchange endpoint reachability information, which means MAC addresses and IP addresses for the endpoints that belongs to EPGs and BDs that are defined internally to the fabrics, okay? We could not use that control plane until now, or a control plane between the fabrics, to exchange external reachability information. So the first thing we did, we enabled a VPN-v4 control plane between the spines, which is in addition to the EVPN adjacency that we already have. And we use that VPN-v4 adjacency to exchange reachability information, external prefixes, right? So an external prefix learned in the L3 out on Site 1 is going to be sent to from the spine in Site 1 to the spine in Site 2. And the spine in Site 2 will redistribute that information to all the local leaf that have the VRF implemented, okay? So Site 2 now knows that there is a path toward that external destination from an L3 out in a remote site. In the data plane, from a data plane perspective, we actually had to create a tunnel, not anymore from a leaf to a remote spine, which, as you remember, was the normal tunnel that we were creating also to enable the namespace normalization function. But now we need to create a tunnel directly from the leaf in Site 2 to the border leaf connected to the L3 out in Site 1. Why this? Because the spine does not store external prefixes information in the COOP database. The COOP database is only used for endpoint information. So the spine cannot do a lookup based on external prefixes destination. So we need to ensure that that lookup is performed directly on the border leaf. So we need to create that tunnel directly to the border leaf. Now, creating the tunnel directly to the border leaf raises a problem if you paid attention to one of the previous lectures, because I don't want to have to know the tab pool, the internal tab pool, or the internal tab address that was assigned to that border leaf in Site 1. I don't want to expose that outside my fabric because it may conflict also with the address that may be not routable. It may conflict with addresses that we are already using other fabrics, right? The internal tab pool is supposed to stay internal. So a third thing that we have to change, we added a routable or external tab pool capability that needs to be configured for each fabric when we want to enable the inter-site L3 out functionality. So basically, we add another tab pool that could be smaller, up to /29, small, that is used to assign a new tab pool to the border leaf so that my leaf in Site 2 can encapsulate directly to that IP address, right? And I choose that external or routable tab pool so that is unique and routable in the inter-site network between the sites, okay? So these are the three things that change, right? The way the tunnel we built, the control plane, and the definition of this routable tab pool. The supported scenario for inter-site L3 out, we can enable endpoint to communicate with something connected to an L3 out in a remote site, intra-VRF, inter-VRF. We can even enable transit routing inter-site. So traffic comes in the L3 out in Site 1, is sent across the inter-site network and go out the L3 out in Site 2. These also intra-VRF or inter-VRF. What is the use case for this one on the right? Well, there are some customers that use the multi-site, the multi-fabric, multi-site domain as a connection metric, as a routing network, as a routed core that interconnects different edge networks, right? Think about state agencies, right? That's a typical use case. We have customers in Australia that want to do this, in Europe. Different state agencies are different edge networks that need to communicate with each other through a common core. That common core is built using Multisite, and the agency connect to the Multisite fabrics, right, using L3 out connection because they are routed network, right? That's a typical example for the use case on the right. As I said, I already covered this. In order to build this tunnel directly, we need this routable tab pool. and Joe will show you, the routable tab pool is configured on MSO, as you see on the top right, and can be from /22 to /29. In case you go small /29 and you exhaust all the addresses in that tab pool because maybe you deploy many border leaf in that site, you can then add another routable tab pool, right? There is no limit. You see there is an add tab pool button that allows you to add more that don't even need to be adjacent with each other, okay? From a control plane perspective, VPN-v4 is what allowed to exchange between sites and external prefix, P1, that is learned in Site 1. But in addition to sending the prefix, we also need to send additional information. And the additional information we need to send, since now we build the tunnel directly leaf to leaf and we bypass the spine cannot perform the namespace normalization, right? So that means that when I send the prefix from Site 1 to Site 2, I need to tell the leaf in Site 2 not only the prefix that that I can reach from the border leaf, but also what VRF VNID to use when encapsulating the packet. Because I need to ensure that when the packet gets to the border leaf in Site 1, the VRF VNID that I have in the VXLAN header is the one that allows to perform the proper lookup in the right VRF routing table of the border leaf, okay? And obviously, as we said before, the same VRF can use a different VNI in Site 1 versus Site 2 because they're different epic domains, right? So instead of relying on the namespace normalization, here we use something that we call downstream VNI assignment, where basically through the control plane, Site 1 tells the leaf in Site 2 for reaching this prefix, use this specific VNID, right? Which is the L3 VNID that identifies the VRF in Site 1, okay? So, and this is the point I'm covering here, where we do not apply namespace normalization translation on the spine. The spine is just a routed hop that allows the traffic, the tunnel, to be terminated directly on the border leaf, okay? So putting everything together, how do things work? When an endpoint wants to send traffic to the external destination, the external prefix, as I just mentioned, is received using VPN-v4 through the spine in Site 1. That information gives me not only the prefix, it gives me also the VNID, and I also know I install also in the leaf in Site 2 the class ID of the external EPG of the L3 out in Site 1. So I can apply policy directly in Site 2. If the policy says go ahead, I basically encapsulate the packet. I add the L3 VNI that was received through the control plane in the packet. The packet goes across. The local spine does the same thing that does in regular multi-site forwarding, which is it changes the source address in the external VXLAN header to use the local overlay Unica step, because we don't want to expose the leaf VTEP, okay, to the external intersite network. The packet goes across the intersite network. It goes across the receiving spines that are just used as
Max, not sure if you can hear us, but he just lost his audio. Okay. He'll be back in just 1 second. Let me pause the video real quick.
I'm back. I think I lost voice. Yes.
This meeting is being recorded.
The phone hung up on me. Maybe it was tired of myself as well. The iPhone was like enough. Okay, so I was saying the traffic goes across the intersite network, is routed through the spine. The spine are just a routed hop in the underlay from this point of view, and is terminated on the leaf. When I get to the leaf, the border leaf will be able to look at the L3 VNI value in the VXLAN header, perform the lookup in the right VRF, and then send the traffic out, right? No policy needs to be applied. No learning of endpoint also happens in this border leaf. So the border leaf will never learn the class ID of the endpoint in Site 2. Why? Because the class ID that the endpoint has in Site 2 have absolutely no meaning in Site 1. And since we don't perform namespace and translation on the spine in Site 1, we don't want to learn information that is meaningless, okay? Which basically means when the traffic comes back, The border leaf will never have the endpoint in the endpoint table, so we'll always send the traffic to the local spine. The local spine will do the lookup, encapsulate to the destination site. The destination site send the packet down, right? So in this direction, L3 out to endpoint is exactly regular forwarding that will happen with multi-site, like we covered before, when the leaf doesn't know the endpoint information. Really, the difference is how to handle the traffic between the endpoint inside 2 and the L3 out inside 1 through the creation of that direct tunnel. Last thing I want to cover, some of the restriction of the current restriction of intersite L3 out. It's only supported with border leaf L3 out using BRF Lite. So no Golf, no SR and PLS handoff for now, okay? For Golf, we'll never do it. For SR and PLS, L3 out is a roadmap item. Is not supported in conjunction with remote leaf, right? So if I have a remote leaf pair associated to site 1 and one pair associated to site 2, I cannot do intersite L3 out between the remote leaves pairs, okay? There are a couple of restriction around service integration and multicast that you can find cover in, you'll see in the slide that are hidden here and also cover in the multi-site paper. What's more important that I want to clarify is CloudSec, okay? CloudSec and intersite L3 out do not work together today, and actually more generically, the definition of the routable tap pools and CloudSec do not work together today. So every time you need to define a routable tap pool, you need to think that CloudSec is a no-go, okay? We are trying to fix this by the end of this calendar year because obviously we need CloudSec to work. If if a customer needs CloudSec to work and he wants to enable intersite L3 out, otherwise it will be stuck, okay? So by the end of calendar year, we hope that this will be fixed as well. With this, I stop, and Joe, go on with part 4 of your fund.
Okay, very good. So, funny enough, the more complicated that you would think the topics are like layer 3 outs and service insertion, which are the last 2 topics, are actually kind of the easier ones because we have all the fundamental other stuff in place. So, let me share everything again. So I switched to Firefox because for some reason Chrome was giving up on me and I decided to stop fighting it. PowerPoint. And I turn, yeah, okay. And don't forget my console. Conrad will get mad at me. Okay. So I'll try to go quickly on this one because this is like a single slide setup. So if you remember, we had done Tenant Brown, we did our VRF, we built our bridge domains, we built our EPGs. Now what I've done at the break was I configured in APIC a layer 3 out, and I called it layer 3 out west, that connects through a north-south firewall. So I basically have set up a layer 3 out through a physical ASA firewall. And that physical ASA firewall is advertising half of the known internet, so 0000/1. Just want to point that out because this will be important when we do intersite layer 3 out. So right now, as it stands, I've already configured the layer 3 out in APIC. You can't really build a layer 3 out in MSO. You can only really associate it. I mean, you can build some of the objects, but all the pathing and stuff like that, you do it through APIC. And why is that good to point out? Because, well, this layer 3 out is site-specific at the moment. It's only physically connected to the site in Amsterdam. I've also built in site number 2, Barcelona, going to a totally different firewall with a different layer 3 out called layer 3 out east, where that particular firewall is advertising only the upper half of the known internet, so 128.000/1. So I've split the internet in half, and I'm only advertising half to each side. And I just kind of wanted to first show you the application of layer 3 outs. And then what I want to do is I want to say, well, I'm going to have an endpoint in Amsterdam that actually needs to get to something in the higher end of the range. So it needs to use an intersite layer 3 out or go to Barcelona to go out to the internet, that intersite layer 3 out notion. So that's my one slide. Let's actually go and configure it. So back to Firefox now. So here I am back in Amsterdam. I just want to point out that I've already configured the layer 3 outs. They're already existing, so don't wonder where these came from. They're already built ahead of time. But what I need to do here is I actually need to import them. I was thinking, should I import them ahead of time because we've already seen this, but I was testing some things and I had to back out. But anyways, I need to import them. So here's my list of things to import. So what I'm going to do first is I'm going to bring in the layer 3 out, just like before. I'm going to untick this relation. Now, normally I would bring in the external EPG as well, but for some reason it's giving me an error. We'll try it one more time. So I'm basically only going to import the layer 3 out and the external EPG. So let's try to import, and we'll click here. Now notice we had a red box. We basically need to tie it to the VRF. And notice we have a little red thing here. We need to make the external EPG tied to that. This is where I'm getting, oh, it worked. Okay, it worked this time. Great. Okay, so everything's working fine. So if I want to deploy to sites, we'll go ahead and deploy. Yeah, everything worked well. Let's do the same thing for Barcelona. I'm going to import real quick from Barcelona, a layer 3 out, right? Layer 3 out east, right? That only lives in Barcelona, and it's external EPG. So external EPG called east. Let's see if that works. We'll make our mappings. Again, this should be not new to you because we did importing already. I'm just showing you what it looks like for layer 3 out. Yeah, worked. And deploy to sites. So that's quickly importing the layer 3 out. Let me quickly show you. I am in, this is the console. Let me increase the size. This is the console of the firewall serving Amsterdam. So Internet West is what I'm calling it. And I basically have used EIGRP in this case just to show you that we do support it. It works. So I'm doing EIGRP to this firewall. And if I do a show route, you can see that I'm seeing some connectivity over EIGRP, right? I don't see any of my BD subnets yet because there's a few more steps I need to do. But I want to point out that statically, this firewall is advertising 000 /1, right? So only half of the internet. So if I go to a leaf in site number 1, and let me increase the size here. If I type the command show IP route VRF brown :v2, so tenant brown : VRF name v2, and I see here, you can see that I am seeing already advertised over EIGRP, because you can see it's an external route 000/1, right? So we know that that layer 3 out stuff is working. The same holds true if I look at a leaf in site number 2. If I do show IP route brown v2, you can see I'm only receiving the other half of the route. This is for Barcelona. This is Internet East. Okay, so let's complete the configuration here. So we know for layer 3 outs, right? We know normal layer 3 out operation that we have to map the layer 3 out first to a bridge domain, and it needs to be done at this level. So gonna be in Amsterdam. You see here layer 3 outs. I just basically need to pick, see, Internet West, save, right? So I'm associating it to the bridge domain. The next thing that we need is, let me just make sure where's my contract? Yeah. All right, I'm just triple checking my contract because I was making, yeah, everything's good there. Okay, so I've attached it to the bridge domain. Sorry, didn't want to get sidetracked. And I also need to, well, if I look at the contract here, external EPG is doesn't have a contract yet, so let's actually do that. So external EPG is going to provide a contract that I created already called iNet West. He's going to be provider, okay? And the AMS client is going to be the consumer of the contract. So Internet West as consumer. And if I deploy to sites for Amsterdam, Internet West was already deployed. Come on. What did I do wrong here? It was working fast.
I got distracted. What did he tell you?
Internet OS is already deployed by Schema Brownfield template. AMS only on-site AMS.
It means it already exists inside in Amsterdam.
Yes, but I just imported it and it's fine here. So what?
I don't know.
Bridge domain maybe? Let's do that. See, it's spinning, and it's making me nervous that the thing is spinning like that.
Better question. Throughout ASA Internet is already deployed by the Brownfield template on site Amsterdam. Yes. So what did you import? I didn't follow the import. Sorry.
I was just basically applying the bridge domain.
Okay.
See, that thing is spinning, and that's giving. Sorry. Yeah, the EIG per neighbor's still up. The routes are still there. Okay, let's let that think for a minute. See, I don't know why that thing keeps spinning. Let's do Barcelona. While that thing still spins. So we're going to go bridge domain. No, we have to do it down here. Bridge domain. We want to attach the layer 3 out. Let's do that first. Internet East. We'll say save, right? Let's save and let's deploy and see if that takes. Okay, here's what we're going to do. We're going to pivot. Good. We're going to do this. We're going to think on our feet. I was testing it like literally while you were talking, Max, and so I think I probably didn't undeploy it properly or whatnot. Here's what we're going to do is we are going to fall back on automation. And we want to send this guy to tenant green. Just basically going to use Ansible to repush layer 3 out to my greenfield tenant this time. Screw brownfield because he's giving me problems. We'll do this one. Okay, let's just double check. My neighbor is up. I got my routes. Neighbor is up. Got my routes. Okay, good. See, so we're going to do this a little bit with a different schema, right? So we're not in tenant brown. We're going to be in green now. So I just want to see if I have any faults or anything. Of course, I have a fault, but it's working. Okay, we'll give it a shot. So let's go to our greenfield tenant, right? Let's go into Amsterdam and do the import again. No. Import Amsterdam. Let's bring in the layer 3 out. just by itself. Then let's bring in the external EPG just by itself. Oh, before I do that, I realized that I'm using a different contract. I'm using the common contract, so let me remove it real quick. Okay, going back here, now we'll import Amsterdam external EPG. There we go. There we go. Import. Yes. So now we just need to basically say external EPG belongs to VRF V1. Layer 3 out belongs to V1. Amsterdam only external EPG belongs to Internet West. Save. That's the thing. Okay. That's this bug. That's what I was saying was not working. We'll do that again. Now this ought to work. Sorry. Save. Deploy to sites. Yes. Everything good. So everything successfully imported, right? Just triple checking firewall, right? EIGRP or neighbor is still up. I still have some EIGRP learned routes so far. So the next thing I need to do, Max, and maybe this is, I don't know, you just keep an eye on me. So what I need to do is I need to bind the layer 3 out to the bridge domain, right? So I'm going to add the layer 3 out here.
Right.
Internet
to
West.
advertise it out.
Yeah.
Yep.
So there's that. I'm going to say save and deploy just to be on the safe side. Everything good. So that's where I got stuck last time, right? Now what I need to do is let's quickly create a contract and a filter. So I'm going to say all create a contract here. And I'm going to call this iNet West. I'm going to go ahead and add my all save. Okay, save. Deploy to site. So I have a contract. Now what I want to do here is I need to provide that contract so that traffic can actually get out. So Internet West is going to be provided. Yes. And then the, let's say client's AMS is going to be the consumer. Save. Deploy to sites. Yes, everything good. Everything's working so far. Okay, so we've recovered so much. Let's go ahead and look at our routes here in the firewall. Notice a few new routes have been added. What are these guys? Well, these are the bridge domain routes from Amsterdam, right? So if you recall, when we built our bridge domain here, I'm sorry, I need to go on your site specific. When we built our bridge domain here, if you remember, we added some networks. And if I click on those networks, I click this button, advertised externally. This is basic layer 3 out routing. So just wanted to show you what it looked like in Multisite. So let's actually go here. This is my Win8 Silver, if you remember. This is the guy that's in AMS clients in site number 1 at 1.11. He should be able to ping, say, something in the lower range, and he can't. Come on. Killing myself here. The route, okay, it's got to be like a contract issue, right? Did I not deploy? Client's AMS is a consumer of iNet West contract. Let's do that again because I have iNet West consumer save. The external EPG is contract West provider. Yeah. Everything should actually work. It was totally working like while you were doing your lecture back.
And now you can show them the beautiful ELAM application if you have it.
Yeah, but it's like almost 5 o'clock, so.
Yeah, I'm saying.
What am I missing here?
So you created a contract between the client, internal client, and the external EPG. Okay.
So in Amsterdam, here's the external EPG.
Yeah.
Let's take out the contract and then we'll.
No, hold on. Before you do, before you show me the external EPG, show me the external EPG again. If you don't mind, go down. Classification subnet. You classify everything. Click on the classification subnet if you don't mind. On the 000. Okay, so that's fine. So traffic comes in. We will classify part of this. We're trying to ping 888, which is on the firewall, and the firewall has the route.
Is your bridge domain advertised externally properly?
Let's go into the bridge domain. Yes.
It advertises out the L3 out, the subnet 1 and 2. So you're advertising both.
I can't make it the VRF unenforced. Maybe I can locally, right?
If it's intra-site, do it at the epic level, right? The VRF unenforced knob will be exposed in a future release, but for now we still do not expose it. If you want to see if it's a policy issue, you could do that.
No. I'm killing myself here. Sorry, guys.
Try the tracer just to see whether it dies.
Oh, I want to do what, -D or something like that? That's the bridge domain. Shoot. Well, when
you do things like you're an acrobat without net, right? So you're trying to do everything live. But, what is the say?
Yeah, but
configuration failed.
F0467, right? Somebody forgot the glue.
Yeah, you have a fault. So you have an invalid path. Show the. Yeah.
But I'm using a routed interface, right? Because the neighbor adjacency is up. See? I'm actually getting the routes.
Yeah.
If I'm exchanging the routes.
But what is the fault? Show me the fault again.
It is the 0467, so it's a traditional.
Yeah, but it's not using a VLAN. It's a direct routed interface, right?
Go to the L3 out again. 1 second. Yeah, click there.
Policy.
Yeah, policy.
It was literally working while you were talking.
And you're using HRP, yeah? You're saying, okay. I don't know, man. Yeah. We should, so just for the sake of who is listening, well, the easiest thing here would be to use the ELAM and see where the traffic is dropped, right? Is it on the receiving border leaf? Is it on the spine? That application is amazing because it will tell you everything, but
don't have it installed.
It's 5 to 5, so maybe, yes. Yeah, exactly.
Okay. But the error was saying that it's the east, not the west. If you take a look at the error again.
Oh, it's west.
I bet I've seen east somewhere.
Yeah, you saw east because in this one I've got the same error in east. Somehow there's a, but I'm like I said, the firewall, I haven't done BCN yet, but the EIGRP neighbor adjacency is up, right? There's no NCAP, there's no VLAN, there's no path. I guess I'll remove that and reselect. Or maybe that's a problem there. Let's see if I have a different domain here because I've pushed it with a script. Maybe that is it. Now, well, I'm not going to waste a whole bunch more time trying to troubleshoot because it's like super late. So let me show you what I would have. Let's pretend the ping worked, right? Because it's really just sort of a proof point. But this is how you would import a layer 3 out, attach it to the bridge domains. I don't think that's anything, let's say, too strange or too foreign because it's standard layer 3 out kind of stuff. If I wanted to do intersite layer 3 out, let's just kind of shift gears real quick. How would I do that? Well, you remember Max said from his lecture that we needed to do external TEP pools. And where would we add that? Well, we wouldn't add that under a template or a schema. We actually have to go into the interface. So in a way, I can still show you the fact that my leaf, right, in site number 1, it's not receiving that route now. Okay, I guess I probably broke something else. Let's see when you troubleshoot, you end up breaking more things. Yes, I guess I totally broke the layer 3 out there. Great. Well, the route was there. So troubleshooting just made it worse.
Maybe what we can do, we can go ahead and then while I cover the last part, you try to recover. If you recover it, you show them at the beginning. Right?
That sounds good.
Yeah.
Let's do that.
Just for the sake of time, so it gives you also more count to figure out, because when you start doing things, then with the pressure, I know how it is, right? So let's move in the last part, right? Which is network services integration, because and I'm not sharing, so that would be good. And obviously, I have the easy part in all this, right? Because the slides don't fail on you, right? I mean, PowerPoint may crash, but you restart it. Joe has the hard part of doing everything live, and is, as I said, he's an acrobat without net, and he likes that. But sometimes, you may hit some issues with that. So let's cover the network services. Let's see if he can recover the L3 out. Otherwise, then he will show you the network services integration. So when we talk about network services and multi-site, I want to clarify what are the integration models, and also the use of service graph with PBR, because really, right, you can integrate services in ACI in a more networking, traditional networking way, where you do VLAN stitching, VRF stitching, and you force through bridging or routing the traffic to go to the service node. But the real value of using ACI is to basically leverage the additional intelligence that ACI gives you, so that through policy, through a contract, you can actually decide how and when to redirect traffic to a service node or more than one service node, right? So really that's leveraging the power of ACI, but that said, there is nothing wrong also in doing a more traditional configuration if you want, because ACI in the end is a network, right? And sometimes we lose a little bit track of that, right? So you can use it as a regular network if you wish so. So in terms of integration model, and this is a slide that I've been using also in the Multipod presentation for quite some time, there are two integration models where basically calls for the deployment of service clusters across sites, right? Here is an example of a firewall. You can do the same for load balancer or other service nodes. And you can have an active standby pair. Across sites, you can have an active-active pair. Now, the deployment of a cluster of firewalls, philosophically, it's something that applies more for a multipod deployment. Why? Because if I deploy a cluster of services across two data centers, it really makes sense if your two or more data centers are operated as a single logical data center, right? I don't really care where my endpoints are, where my application components are. It's all distributed, and so the services are distributed as well, right? Compute resources are distributed as well. That makes sense with Multipod. With Multisite, we can do something for active standby and active-active, but actually for active standby, we can do something. We have limited support. I show you an example of connecting an active standby firewall pair to L3 out, which we can make it work with Intersite L3 out today. We can have an active standby pair of firewall across sites if the firewall is the default gateway, because at that point, ACI and Multisite only performs layer 2 forwarding, and there is no problem, right? But other than that, using, for example, service graphs with an active standby pair does not work, right? Because I cannot do a PBR redirection from site 2 and redirect the traffic to a node in site 1. The PBR redirection service graph is applied always locally to the site. So philosophically and architecturally, it makes sense with Multisite that each fabric is its own network. Each fabric has its own set of services, okay? And that's why usually we see independent fabrics with independent services being brought together with Multisite, and what Multisite needs to ensure is that you do not create asymmetric traffic path. As I said, option one is to use some networking mechanism. If you remember the slide where we're talking about north-south with a stretch subnet, the use of host route advertisement was a way to make the traffic symmetric, right? And that allows you to deploy independent perimeter firewall in each site. But what I want to focus here is actually more the option two, where we, as I said, we use the intelligence of ACI and Multisite to basically ensure that even if I have independent firewall deployed in each fabric, no matter if I want to do north-south or east-west, I ensure that I always use the same set of services for the two legs of the same flow, right? And I'll show you how that actually works. Now, the key point is, though, that if I go back 1 second, as I said before, when you do this option 2, when you use PBR, which is the main focus of this section, with Multisite, the redirection today always and only happens inside a site, which essentially means you need to ensure that the service that you deploy in that site is actually resilient, redundant, right? How do you ensure that? There are 3 options, right? One, you can deploy a classic active standby pair. Here again, the example is the firewall. I can deploy in a site an active standby pair. My active node goes down, the standby comes up, and my firewall service is still there. If I'm not okay with just, I want to handle a dual failure scenario where I lose both firewalls, I could deploy a cluster with more than 2 nodes, right? That's what we usually refer to as active-active cluster. For example, with the Cisco FTD or the ASA platform, we can have up to 16, I believe, firewall nodes part of the same active-active cluster, right? So that allows me to build more bandwidth, more throughput capabilities, and also more resiliency into my firewall service. Or I could do also the option 3, where I deploy independent set of nodes in the same site, right? And each of these nodes could be an active standby pair. I could have active standby pair 1, active standby pair 2, active standby pair 3. The difference between the option 1 and 2 and option 3 is that in option 1 and 2, when I define my PBR policy, I have a single node in the PBR policy, which is the firewall that the firewall cluster, if you want, okay? Because it looks like a single object. In the option 3, each firewall, it's a different PBR node, but I can put 3 MAC IP pairs in the same PBR policy, and then the use of symmetric PBR, which is how ACI works by default, will ensure that traffic flows will be hashed across the 3 PBR nodes so that the 2 legs of the same flow will always use the same firewall. Okay, so I use for flow 1, I use the firewall 1, for flow 2, firewall 2, for flow 3, firewall 3, right? So the system, symmetric PBR makes it symmetric by definition, right? And by denomination. So these are 3 ways to make the firewall service more resilient. Now, when we talk about using service graph with PBR, we have a scenario with Multisite, a single node service graph scenario has been supported from ACI 3.2.1 when that single node is a firewall. And this is the scenario, right? I have an EPG provider, 1 consumer. There could be 2 internal EPG east-west or 1 external EPG and internal EPG north-south. And I redirect the traffic in the 2 directions to the firewall, okay? Joe, I think you're still not on mute. Can you put on mute when you get a chance? So ACI 3.2.1, we will see we were applying the policy on the consumer leaf. We changed that in 4.0.1. We apply on the provider leaf, but the mechanism is the same, right? We support single node being the firewall with service graph from pretty much 3.2.1, okay? When the single node is a load balancer, there are 2 scenarios. I covered them because this is also something that I've been asked very often. There is some confusion sometimes. If I use a load balancer with a SNAT, I don't need service graph or PBR at all, right? Why? Because traffic between client and server farm is sent to the VIP, right? Now, that VIP could be learned in the fabric through an L3 out, or it could be learned in a BD if I connect if the VIP is taken out of the interface or the load balancer connected to a ACI bridge domain. The point is I just route to the VIP, right, in that direction. If I do a SNAT, it means when the traffic leaves the load balancer to go to the server farm, I use an IP address which identifies my load balancer. So the traffic back from the server back to the client is first sent to the load balancer because of the SNAT functionality, right? So there is no PBR requirement at all for this type of integration, and this has been, as a consequence, supported from the beginning, right? There is no, it's just forwarding to IP addresses, right, which Multisite does from its birth. What we introduce in 4.0.1 is instead the support of a single node service graph when that single node is the load balancer that does not do a SNAT, because in that case, client to server, we still route to the VIP normally, no PBR needed, but the response from the server farm back to the client, we need to use in that case PBR to redirect the traffic to the load balancer, right? Otherwise, we would bypass it and go straight back to the client, and the client will drop it because the source IP will not be the VIP, but will be the server in that case, okay? So this is supported from release 4.0.1. We also support dual node. Again, dual node is the scenario on the right. The scenario on the left, you see 2 services, but since we use source NAT, from a PBR perspective, is really a single node PBR because I just need to redirect the traffic to the firewall, okay? To the load balancer is just a routing that takes the traffic in and out of the load balancer. But on the right, from client to server, I have redirection only to the firewall and then route to the VIP. But from server back to the client, I have a 2-step redirection. First, I send the traffic to the load balancer, then I send the traffic to the firewall, okay? And so these also supported from ACI release 4.0.1, okay? And is the reason the support for these 2 nodes service graph with load balancer is the reason why we changed the implementation for east-west and we move the application of the PBR policy on the provider leaf, which I will cover in a second. So how does it work? Service graph and PBR with Multisite, and now does it help with that specific use case that we discussed about asymmetric traffic for north-south, okay? So imagine I have, let me skip this, let me go here directly. Imagine I have the same scenario I had before, site on the left, site on the right, I have a firewall, active standby pair, in this case in site 1, active standby pair in site 2, and I go my multi-site orchestrator and I define the policy that says, okay, external EPG, so the external world wants to communicate to web, which is an internal EPG, I want to redirect that traffic to the firewall, right? And when I do PBR, as you may know, I can decide that all the traffic between these two EPGs needs to go to the firewall, or I can specify only the traffic that matches these specific rules needs to go to the firewall. Everything else is enforced at the fabric level, right? So I have flexibility between redirecting everything or redirecting only a subset of the communication that I specify using the filter rule, okay? But assuming I say everything, it means that when the external user tries to send the packet into the fabric, the first thing that will happen, the packet will be received at the border leaf. Now, the border leaf for north-south traffic will never apply the policy, okay? The policy is applied on the compute leaf. So the first thing we do regular forwarding, and let's say the user in this case wanted to communicate with a 10-10-10-10. The traffic gets to the border leaf and is forwarded inside the fabric to get to the compute leaf. When I get to the compute leaf where 10-10-10-10 is connected, my endpoint is there, but I cannot send the traffic to it. Why? Because in my intent, I said that external EPG to web, I need to redirect to the firewall, right? That's what I configure on my MSO. So what happened at this point is that the PBR policy is applied on the compute leaf, and you redirect the traffic to the firewall or to the firewall service that is deployed inside Site 1. Okay? As you remember, if I deploy different PBR nodes in Site 1, I will pick one of them, right? If I have a single cluster, I will pick that single active node in the cluster, okay? The traffic goes to the firewall applies the policy, sends the traffic back to the fabric, and the fabric at that point delivers it to the endpoint. The same thing will happen if for some reason the traffic comes in L3 outside 1 and the destination is the .11, right? We do forwarding, so Multisite does its job. The border leaf in Site 1 sends it to the local spine. The spine is like, okay, where is .11? Site 2, boom. VXLAN encapsulate the traffic, send it to Site 2. When the traffic gets to the compute leaf in Site 2, I need to honor my intent, so I apply my PBR policy there. And that means I redirect now the packet to the fabric, to the firewall service deployed in Site 2. Okay? The firewall applies this policy, and then traffic is delivered to the endpoint. So you see that for incoming traffic, right, the policy, the firewall that is used is always the firewall in the site of the internal destination. Okay? Left when I want to talk to .10, right when I want to talk to .11. Now, if I were to send host route advertisement out of the fabric, I would optimize things because I would avoid that packet to basically come to the border leaf in Site 1 and have to cross the inter-site network. But functionally, even if I do this suboptimal path, I don't break things. Why? Because when the response comes from the endpoint, let's start first from the endpoint in Site 1, I reapply the policy at the compute leaf in Site 1, and so the packet is sent to the firewall. So the SYN came in to this firewall, the SYNAC goes back to this firewall and then out. More importantly, from the endpoint in Site 2, I do the same thing. I apply the policy on the compute leaf for the return traffic. So I go through the same firewall that I did for the first leg of the communication, for the inbound flows. Then the packet may be delivered to the external user using a local L3 out, but the fact that I use a local L3 out doesn't mean that I created an asymmetric traffic path across different firewalls, because I always use, for both legs of the communication, the same firewall, okay? And that's the critical point that ensures that the traffic is not going to be dropped, okay? So host route advertisement, in this case, is an optimization, is not a mandatory thing to avoid the creation of asymmetric traffic path, okay? This is for north-south, because again, in north-south, the policy, the PBR policy is always and only applied on the compute leaf, okay? And we support today north-south only in the context of the same BRF. So the L3 out and the internal bridge domain needs to be part of the same BRF. What about east-west? So in the case of east-west, both leaf are the compute leaf, right? Because I have communication between two endpoints, two internal endpoints. So what we need to do in this case, we need to ensure that we anchor the application of PBR on only one side, the web or the app in this example. what do we leverage for anchoring the PBR policy on the one side? We leverage the fact that a contract between two EPGs always have a provider side and a consumer side. I know that many of you may do or may have seen customers creating contract and providing and consuming a contract from all the EPGs, but that makes no sense because logically, right, you always have an EPG that offers a service like a web server, and you have another EPG which is the client which consumes that service, right? It tries to connect to a web server. And if you have to reverse the functionality, you should use a different contract because it's cleaner to understand the relationship between these endpoints, right? So assuming that, and this is a mandatory thing, that between a pair of EPG, you apply for a given contract a clear differentiation between the provider and the consumer side, we basically ensure that the PBR policy is always applied on the provider leaf. That's what the multi-site architecture ensures. So in this example, EPG Web is providing a service, EPG App is consuming. I stick a service graph with a firewall in the middle. What happens is that EPG Web sends a packet. Since EPG Web is the provider, is connected to the provider leaf, the PBR policy is applied right away there. So I redirect the traffic to my firewall in my local site, and then the firewall does its job, and then send the traffic back to the fabric. The fabric forward the packets to the destination endpoints. That EPG app could be in the same site, could be in a different site. I don't care. I reach it through forwarding, okay? The important point is that when EPG app responds, I do not apply the policy on the EPG app leaf because that's the consumer leaf, okay? I just do forwarding. I send the traffic back where my provider endpoint is connected, and only then I apply the PBR policy again, which as a result, I send the traffic through the same firewall that I use in the direction web to app, okay? So anchoring the PBR policy application on the provider leaf ensure that I use for the two legs of the traffic the same firewall. I don't create an asymmetric traffic path. How do we anchor the PBR policy on a leaf? Is by configuring today in a static way the subnet under the consumer EPG, right? So in this configuration, I need to go under the consumer EPG, which is something that you guys may be familiar with to do VRF route leaking, even in a single fabric deployment between two EPGs and different VRF, right? In that case, you need to configure the subnet under the under the provider, EPG, so that is leaked in the consumer VRF. Here is the same concept, right? Under the provider EPG, I configure the subnet so that I got it wrong, I knew it. Under the consumer EPG, I configure the subnet that EPG belongs to so that I can install on the provider leaf that subnet with the corresponding PC tag that identifies that EPG, okay? What is the consequence of that? The consequence of that is that this mechanism really works today only in network-centric mode, right? So if each EPG is associated to a BD with its own subnet, then I can do that. You understand that if I had three EPGs in the same subnet that the EPG app belongs to, it would not be possible to apply a subnet under the EPG app because it may include endpoints that are actually not part of the EPG app. So I may start redirecting traffic for destined to endpoints that I don't want to stick a firewall in between, okay? So this is a restriction of east-west service integration today with Multisite. It can work intra-VRF or inter-VRF, but only when I have a network-centric approach where an EPG is mapped to a BD. We check with lots of customers, and to be honest, so far I have two cases where this was a problem, right? So if you have customers that you know they want to deploy east-west service integration with Multisite and they want to go application-centric today, you need to let me know because only if I see more demand, we'll have engineering implementing something because it's not an easy nut to crack to solve that problem. Okay, the majority of the deployments we see are still network-centric, so this will work without any problem. With this, Joe, I don't know what's going on your side, but it's lab time part 5, I believe it is, not 4, to show the service integration. unless you quit because of you're disappointed
No,
of your lab.
no.
Okay.
I literally just quickly tried to rebuild something really quick, and I believe I have it working. So let me just do one thing before I go mad. That's not, one half is working. Nah, Max, I needed like 5 more minutes. Okay, BCN servers. He's a consumer. Sorry. You know what I'm gonna
do? I can address some question while if you need a few more minutes. Let me address some questions. So there was a question about Jan was asking, do you have to define the redirect twice, once in both directions, so 2 contracts to redirect to the firewall? I assume you talk about east-west, and if it's about east-west or even north-south, doesn't matter. You just apply the redirection is between the 2 EPGs, and you just have a contract with a provider and a consumer side. In reality, provider and consumer does not matter for north-south because, as we said, the policy is always applied on the compute leaf, on the internal leaf. For east-west, you apply your contract with a provider side and a consumer side, right? Provider EPG, consumer EPG. And then the redirection happens in the 2 directions automatically. You don't need to do contract in the 2 directions, right? The contract, as you know, when it's defined by definition is bidirectional. There are the 2 options that essentially ensure that if the client is accessing port 8 on the web server also can respond sourcing from port 8 back to the client. Okay, this is handled under the hood when you define the contract. The important point is you cannot configure a contract. Don't do EPG client, consumer provides the contract, EPG server, consumer provide the contract, because if you do that, you break things, because we don't know anymore who is the consumer, who is the provider. We don't know anymore how to stick the policy on one side. Okay. Hopefully that was clear. Let me see if there were some suggestions to fix your lab. I don't know if you see them about the VRF name. I didn't check the VRF on the entry out, but okay. Maybe you already checked that. Okay, Jan was east-west.
I'm just gonna go to the service insertion one because I got it half working, but I needed like another maybe 15, 20 minutes. But I'm not gonna make people sit here all day and night waiting for me. It's a failure on my part. What I will do is I will make it work. I will record a short video and I will put it in the box folder for you to actually see it working. Trust me, I'm more bothered about it than you probably are because I really, really, really wanted you to show this stuff working, and it does work. I can validate that it does in fact work. Yeah, for whatever reason today, the gods are not with me, and I'm just going to swallow it. So, okay. With that being said, let me go. Change flow. I'm the presenter. Okay, so let me share my applications again. And I know what the problem with that fault was. It was a cosmetic fault because I didn't actually build the actual physical, the interface policy group, blah 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 blah. And so if you don't actually have that, you'll get a fault. But it was working, right? Because the layer 3 out was up. So it was kind of a cosmetic fault. So I'm not worried about that. So let's go back here. I created a whole new tenant here. Let's see if we can get this one to work for service insertion. So I don't have slides for you for there. I ran out of time because I was troubleshooting some other stuff earlier in the week, but so I'm just going to kind of walk you through it. So what we're going to do is we're going to create a service graph, an unmanaged service graph for an east-west firewall Now, I have in my environment two firewalls here, ASAV S1, ASAV S2. And as you can see right now, they're just basically, I need to make sure I access this guy. Sorry. These guys are just basically sitting here with only management connectivity. There's nothing actually configured. So the first thing that we need to do is we need to go into, because I have an ASA for site 1 and I have another ASA for site 2, right? So they're two different ASAs. What I need to do here is I actually need to build the L4 through L7 device and the sort of framework of the service graph inside the APIC. You cannot build service graphs through MSO. You can only apply them, right? So here I am in my new tenant called Joe, and I'm going to go through into services. Let me see if I can increase the size and go to L4, L7. And the first thing I need to do is actually need to create a device. So I'll right click. This is, let's say, standard unmanaged service graph so far. So this should be quite familiar to most of you if you've ever done a service graph. So it's going to be unmanaged. I'm going to call this ASAV 2020 Site 1. It's a virtual ASA, right? I already have VMM integration. So what I'm going to do here is I'm just going to, oh, I'm in site number 2. Okay, so I'll do this for site 2. I was in the wrong APIC. And then, so I've selected my VMM domain integration, which will be important in just a moment. If we go over to the right, oh, no, I always do this too, make sure that that says firewall. So everything looks good there. My firewalls are actually configured as one-armed firewalls, right? So what I've done is I have a single connection to a firewall interface, and traffic can go in the firewall, get processed, and then come back out that same interface in the firewall. It's a common deployment, and we're going to use something called PBR to actually redirect traffic to that firewall, and everything should work. So let's give it a name here, and now we need to select a VM. This list of VMs is coming from my VMM domain itself. So I need to pick, where is that guy? Site number 2, and click next. So the next thing I need to do is tell ACI about the firewall's interfaces. Now I only have one, so that's going to be pretty easy. So I'm going to click plus, and I'm going to call this one arm. It's just the name that I'm giving it. And I'm going to select the interface that I have configured on my firewall that's one arm. Note, if you're using a virtual ASA, just like I am, network adapter 1 is always the management interface, so make sure you pick something other than 1. So in my case, I'm using network adapter 2. So I'll go ahead and click update there, and then I'll say OK. So I've got that interface here. Now I have to tell it the sort of cluster interface is basically the same thing, but it's what's needed to make the mapping between the logical and the physical. So I'm going to give it a name, one arm, and I'm actually going to select the concrete interface that I just built up here, right? And we'll say update, right? So then we'll finish. That's the first thing we need to do. That's basically told APIC that you have an unmanaged service graph with this, using this device and these particular interfaces, and I attach it to the VM. The next thing we need to do here is not under services, but under policies, and we need to go under protocol. And we're going to do a PBR, policy-based redirect, right? So what that's actually saying is we're going to use policy to make a forwarding decision instead of just next hop IP, right? So we're going to create that policy, which will then allow us to apply this firewall east-west and say when this EPG is talking to that EPG using this contract, it's going to redirect to the firewall, and then traffic will go through the firewall as opposed to going direct. So let's create our redirect policy here. So we'll just give this ASAV site 2 PBR. All these defaults are fine because I want to do a layer 3 redirection. We do have the possibility to do layer 1, layer 2, but I want layer 3 redirection. So let's actually tell it what the IP and MAC address to actually redirect to. So I need an IP and a MAC. So where do I get those? Let me minimize. You can see my terminal, right? I'm sharing the terminal. Max?
Yeah,
you are.
Okay. So let me log into that firewall real quick. This is the firewall in Site 2. And let me show interface gig 00, which is my one-armed interface. You see it's called one-armed. I've already got that configured. I need the IP address, which is 172.16.100.20. So I'm going to paste that there. Now I need the MAC address. The MAC address is there. There is one small problem, though, is APIC wants the other MAC address format with the colons. So I have to manually go and fix that here. So APIC will be happy with it. That's the format it wants, okay? We'll say, okay. That's really all we need to do there, right? So we're gonna say, yeah, we're good, right? We're gonna do the same thing in APIC number 1. So let's actually quickly do that. Under Joe, under services, L4, L7, same thing. So I'll go fast is devices. Create the device for site number 1. Think about it. Okay. Unmanaged, so untick the box. So ASAV 2020 site 1. It is the firewall. It is virtual, just like before. This local VMM domain that's specific to site number 1. We'll do the same thing here. We'll set up our device. We'll choose our VM. This is by courtesy of the VMM integration. Here we're going to say same thing, one arm, select the VNIC, same thing, network adapter 2, update. Do the same thing for the cluster interface, one arm maps to, why is S2? Oh, that's the name I gave it. Should have done. Do that. Let's do that right. Let's not chance any error. S1 and S1. Okay. Now this is going to be right. Yep. Okay. That we'll click finish. We do the same thing for the PBR redirect. This will be the redirect for the firewall in site 1. Same kind of thing. So let me go very quickly here. And we do the same kind of thing here. So what's the IP address of the firewall S1? We'll quickly log in. And this IP is 100.10. And the MAC address is this. Again, we need to quickly correct the format. And we're good. Okay, so now what I need to do is, now that I've got my devices built in APIC, what I need to do is I need to go back to Multisite here. And what I need to do is I need to create a stretch BD that I'm going to call the services bridge domain. This is going to be a bridge domain that I'm going to connect that one-armed interface of the firewall to. It's just a stretched BD that's going to exist in both sites. So let's put that under common items. Right? All we're going to do is create a bridge domain here, and we'll call this services underscore BD. We'll attach it to our VRF. It is, Max, I don't need bump traffic, right? I just need L2 stretch, correct?
Correct.
Okay, so I'm just going to turn off the bump traffic and allow L2 stretch.
But it needs to be stretched, right? So this needs to be stressed this point. The service BD needs to be a stretch BD so that all the firewall in the different sites connect to.
Right. So because it's a stretched BD, I'm allowed to assign the subnet here at the template level because it's going to exist equally the same in both sites. So it's 172.16.100.1 is going to be my bridge domain. Okay, and we need to give it a mask, of course. And we'll say save, right? So we'll say save. And let's deploy that to sites just to get that done and out of the way. So now, the next thing that we need to do after we create that services subnet is we need to actually instantiate the L4, L7 services device in MSO, right? So let's go here to Amsterdam first, and we're going to go down here to the bottom, and we're going to click on Service Graph, and let's just call this ASA S1 graph, right? And what that does is we go to this little sort of workspace down here, and we're going to click on firewall, and we'll just drag firewall down into the window, right? And we can see that we've got this firewall. Now notice things are kind of changing here, because if you go over here to Amsterdam, you see there's the service graph, and we need to, because this is only living in Amsterdam, we need to click here and actually select our device, and there it is, right? Max, I always forget where I apply the services BD.
The service BD, it's so at the site level. No, so did you already assign the service graph to the contract?
No, I haven't.
Okay, so when you do that, then at the site level, that's where you specify the service BD.
Okay. So let's create a contract.
And the PBR policy, as well. Yep.
Okay, so this is going to be my C-PBR. Gonna make a contract. Let's go ahead and add a filter. And this is where we attach the service graph to the contract. So we'll select our service graph 1. Yeah, and this is down here. We have to click. Yeah, this is what I got stuck on. So it's basically saying, for this service graph, for this firewall, right, there's going to be a next hop for each of the interfaces involved. Well, in my case, I've only got one interface. It's one arm. So when I select my BD, I'll select my services bridge domain for both the provider and the consumer. What that means is one-armed traffic's coming in and going out the same interface. I think you understand that. So we'll say done. Notice I get a little red mark. We need to go here, go into the contract, and set our cluster interfaces. Remember, the cluster interface is when I built the device in APIC. So there's my one arm, my redirect policy, PBR-S1, one arm, same redirect policy here, right? So in this particular case, well, let's go ahead and say provider must be associated to contract. I think what they're saying is I need to attach the contract here, right, Max?
Yeah.
So let's take my PBR contract. Let's make this guy the consumer. We'll say save. Now, this is also a special case. Max, maybe you can help me explain it a little bit better. But what we need to do only on the consumer side of this relationship is we have to add a subnet under the EPG. Right?
Under the EPG, because we want to stick the application of the PBR policy on the provider leaf. So this is done basically manually if you want, right, or statically, by specifying the subnet, which doesn't mean that this is the subnet used for networking, right? The subnet for networking is still defined under the bridge domain, and it should remain there. This is just to program that subnet on the provider leaf and add the information that we need to redirect there, right? It's a static way to inform the system about that.
Okay, so we'll put that under the EPG, and I also want to notice that I tick this box, no default SVI gateway. Why did I tick that box? Because I don't want the subnet under the EPG to take over forwarding duties from the bridge domain, which also carries that route. This route, as Max said, is really just for policy, security policy, contract enforcement, right? So we can know which S classes and filters and contracts to apply when we're using this kind of multi-site across different sites kind of thing. So I'll do that. We'll say deploy to sites, and I don't have a I guess I got to do it over here too, don't I?
So you apply the contract. Did you apply the contract also? So you define the contract. Now the contract at the site level, that's where you need to specify the, where did you put the contract?
I put the contract as a consumer under the site level.
Oh, not in the common? You didn't define in the common? Okay. I would have defined in the common.
It's here, yeah.
Okay. Should be okay anyway. So now we go at the Amsterdam level. Yes, if you click on the contract. Right, click on the service graph. Did you already specify? Okay, one arm. Yeah, PBR, okay. So what did it tell you? Provider EPG or external name must be associated to the contract. Since a service graph.
I haven't done my provider yet, so.
Yeah, you didn't configure the provider. That's what it's telling you. Yes.
So what I need to do here is create the other firewall here. So I'll do the same thing with the service graph. So we'll call this ASA S2. S2.
No, wait a second. The service graph is only one, right? The service graph is one. And you create the service graph in the common, usually in the common template, right? Did you define the service graph in the specific site template?
I'm sorry, say again, Max?
Did you create the service graph in the specific site template or in the common item template?
In the specific site template.
If you don't mind, can you delete it and quickly redo it? Because in my mind, it makes more sense to do. Service graph is something that we want to apply in this case for East-West. So you will create that service graph into the common template together with the contract as well, right? And then configure things in both sides at the site level, right? So let's quickly do that just to be sure we avoid any issue. So in the common, I define the service graph. Service graph is one, right? And you say, well, call it whatever you want. And your service as a PBR, you add the firewall, right? And then, perfect. When you do this, then you see at the site level, you need to specify which firewall do I want to use, and each site will expose, right, his own firewall.
Right.
Yeah, go ahead.
Yeah, site 2 for site 2. Thank you, Max. I started out wrong.
No worries.
So now we need to do the contract as well. Create a filter for everything. We'll create a contract here, and we'll call this C1 PBR. Take 2.
And by the way, that filter for everything means that you want to redirect everything to the firewall once you attach the service graph, right, to the contract.
Yep. So here we are back to applying the service graph. We'll click here. We set up our services BD, and done. We have our little red marks here. We need to go into the contract, select our cluster interface and our redirect policy. So notice that's going to site 1, and this is one arm, and this is going to site 1. So we'll say done. And then we'll do the same thing for Barcelona. Click on the contract, click here, make our selections one arm, redirect policy for site 2. Right, notice it's for site 2 specific. We'll say done. Okay, so now if I save, oh, I haven't applied. Okay, so we're gonna make this guy is going to consume this guy. He's going to be a consumer. So we're going to save. This guy is going to be the provider. So here is the provider and save. And let's save and deploy to sites. BCN. Good. And deploy to sites. AMS. Good. Don't know why common wants to be deployed as well, but I guess we'll move the graph. Okay. Just because I'm a little scatterbrained today, Max, have I missed anything at this point? I think everything is good,
It
right?
seems good. Yeah, I think it's good. Yeah.
Okay, let me just triple check that Win8 Silver is in Joe Amsterdam user, so he's my consumer. And then Win8 Pod 2, not Pod 2, Site 2, is in, no, he's in the wrong group. So let's fix that first. We need to put this guy, because he's our server in Barcelona. So this guy right here. Yes. And we'll say, okay, so they're good. Now, if we look at our firewalls, I also want to point out something happened. No, I guess why haven't they? Oh, I'm sorry, no. Well, that's the wrong one. Go to the right firewall, dude. All right. So I want to point out something has happened when we actually deployed the service graph and the contract to the site. A shadow EPG was created automatically by MSO, and it automatically put the firewall interface in the proper shadow EPG/port group in order for the redirect to work, right? So the test that we want to do first is, can this guy, today's not my day. I'm going to laugh later, but I'm going to drink a lot. Okay, so can
Drinking is always
1.11,
good.
can
We don't see,
1.11
are you
ping?
sharing, sorry, are you sharing the, you're not sharing the VM?
Always forget that. Okay. This one, right? You're seeing my remote console now?
Not, yeah, now it's coming, yeah.
Okay. So can this guy at 1.11 ping this guy in the servers in Site 2 at 3.110, right? And he can. But how do we know that it's actually being redirected to the firewall? So what we're going to do here is, okay. We are going to use the firewall on the provider side. So we're going to use a sort of a live capture. So capture Joe sucks. Joe sucks.
Don't be hard on yourself.
Interface one arm, because that's the name of my interface. Yes. And then we say real time, right? Did I get that right, Max?
Yeah, that's perfect.
Okay, so right now we basically have a packet capture going. So just to prove that it's being redirected, let's go ahead and send pings. And you can see the firewall is in fact seeing a ping from 1.11 to 3.110. You know what, Max? It actually worked. I've recovered ever so slightly, but I'm still going to drink a lot.
Maybe, Joe, you want to show to the same capture on the other firewall, if you have it, right, to show that the other firewall doesn't see any packet, right, because that's the key, right? Because depending on what you do, you may see the packet going through both firewalls, but really here, the point is we need to have the two legs going through the same firewall, right? There you go. That's what I want to see.
Okay, so we've got, this is just ARP, right? It's not ping, it's just ARP. Let's actually bring this guy side by side.
And do a continuous ping so that you will be able to.
Right, so let's actually get a ping going again. So you can see ICMP here and not ICMP there. So just ARP, that's other unrelated things, because I'm basically capturing everything on that interface. So makes sense?
Yeah, and just to add to the question that was asked by a gentleman that maybe everybody else also could use, the question was, what if I demotion things around, right? Well, we are talking east-west in this example, right? And as we said, the policy is applied on the provider leaf, right? So if you demotion around the consumer VM, nothing will happen, and the same firewall will continue to handle the communication, the two legs of the communication, because the redirection happens in the same site, because the provider VM didn't move. If you were to move the provider VM to a different site, then at that point, the redirection will start happening in a different site, which means I will start sending the traffic to a different firewall instance, right? Which essentially means you will have to create again the connection, reestablish the connections, right, for that specific communication, okay? Because this is not a firewall cluster. The state is not synchronized between the different instances of the firewall, right? So again, I'm mentioning this to make the point that if you have a customer that brings a requirement, I want to be able to remotion things continuously around my data center, a bell, a ring should, a bell should ring in your brain that's like, okay, wait a second. Multipod is probably the right approach, because then I can deploy clustered services across my data center, across my pods. And at that point, it doesn't matter if I move things around, I will never drop the connections, okay? Multisite is not the architecture to handle this continuous remotion of things around. You may remotion things because of disaster recovery. You can do a plan migration of endpoints, but not a full migration of things all over the place. If you do, you need to keep in mind what the behavior that I just described. With this, and I see that Joe is still trying to recover the L3 out, because it's a matter of pride, rightly so. Because
it is a matter of pride. But before you go, let me just show you one where we actually set those external TEP addresses, right? Sorry, I just want to see if it shows up or not. Okay, so yeah, I am seeing, well, at least 2.x. So where would I go and set those? So we don't do it at the schema and template level. This will take me 30 seconds tops. We actually do it at the infra level. So I'm going back in MSO to the infra configuration and configure infra. Remember these guys here from very early this morning? Well, if I click down at the pod level, sorry, there is a bug that the thing doesn't light up, but I am at the pod level. You see this area that says add TEP pool. So what I'm going to do here is for pod 1, I'm going to add a TEP pool, external TEP pool there. I'll do the same thing for pod 2, because we would want Multipod to work as well. And then we go down to Barcelona, same thing at the pod level. We're going to add a different, unique external TEP pool. Before I push that, let me make sure. Yeah, 101. Sorry, 101, 102. Yeah, okay. So in this particular case, we can deploy, and what this will actually do is allow the intersite layer 3 out communication to work. So let's actually look at something over here. Show IP route VRF all, because I forget what my VRF is called. No, I guess I don't have it set up. So that's fine, I guess. I'm trying to think. I don't have the other layer 3 out working, so it's not going to work. But effectively, let's pretend for a moment what I would see. If I attached the layer 3 outs properly and everything was working, remember this guy right here was receiving from a directly connected firewall this half of the internet. And his next hop is actually a directly connected interface, right? When you see the intersite layer 3 out working, you would see, in this case, the leaf in site number 2, we would see the 0000/1 received from Amsterdam site 1's firewall, and its next hop wouldn't be an address like this. Its next hop would actually be a tunnel endpoint that points it right back to site 1. So unfortunately, I can't show that to you. You have to kind of imagine it, but you would see both routes in the routing table of a given leaf, one for a locally connected firewall and another one for the remote intersite firewall, pointing to a next hop of a tunnel address, not a physical IP. So unfortunately, I can't show it to you, but that's how you would do it. And I'm going to stop sharing. I will record a video tomorrow and post it with all the other stuff. So let me stop recording, because we've gone way over. For the 165 people who stayed, you guys are my heroes. I owe you for all of your patience and working through this. I will make it up to you, I promise. I promise. Are there any last words, Conrad or Max, that you would like to say before we close?
Nothing on my side, Joe. I thank everybody to 165 heroes that resisted till the end. Hopefully this was useful content that maybe you will need to listen a few times to digest, but that's why we did it, right? So you have some reference.
Yeah, and you know what I'm thinking, and maybe you guys, when you do the survey, which I didn't send out, let me see if I can get the survey from Katka. I'll email people. So, I'm thinking that because normally Max and I would want to do this in person live. It's much better, but because we had to do it remote, it becomes a little bit more difficult. This would probably be better served if we did 2 half days instead of 1 full day. Sort of do a few sessions, end around 1 o'clock, and then tomorrow do the other half, right? So I think that's what we'll do for the future. So thank you all. Nothing more.
All right. Have a good day, guys. Thank you.
Cheers.
Thank you, Joe.
End the WebEx.
Bye-bye.
Have a good evening.
Everybody's asking about the recording. What are you going to do for the recording? I'm
going to get the attendee list from our coordinator, and I will email everybody links to all the recordings, and I will put the box folder as well in that email.
Excellent. All right. Thank you very much. Thank you, guys. Have a good day.